All right, so what does a chemical formula represent? So this is a chemical formula, okay? And if we recognize these letters, these are our chemical symbols that we use to represent elements on the periodic table, okay? This one is a very common, very familiar element, okay? This is how we chemically represent water. Water is made up of 2 atoms of hydrogen and 1 atom of oxygen, and we call it H2O. So the directions for this activity say, count how many of each type of geometric shape. Drag the chemical formula to the corresponding symbol. Okay, so when you look here, we have 2 shapes, but they're different. They're different sizes. This one's bigger and this one's smaller. Okay, but there's 2 total shapes. 1, 2. And if you look down here, we have 1, 2, 3 shapes, but 2 types. So we got 2 circles and we got 1 rectangle. So 2 types of shapes, a circle and a rectangle, but we have 3 shapes total. Okay? So the way I want to break this down for you is that the shape, the type of shape represents the element. Okay? The element. And then the number of shapes represent the atoms. Okay? So I like this example the best because you can see the difference. We have 2 circles. So the type is circle, but we have 2 of them. If we look at our compounds, which one of these do we have 2 of one element, but we have, and then 1 type of another element? So with sodium chloride, we have 1, 2. We only have 2 atoms total. Okay, we have 2 elements, but there's only 2 atoms. With H2O, we have 2 elements, H and O, but we have 2 hydrogens because of that subscript and 1 oxygen. So we have 3 here and we have 2 here. So this H2O goes right here. The circles represent hydrogen and the rectangle represents oxygen. We have 1, 2 hydrogens and 1 oxygen. Then we have NaCl. We have 1 atom of sodium and 1 atom of chlorine. Okay? Notice that there are no subscripts in NaCl. There's no numbers here. We don't have to write a 1 here. Just having the chemical symbols tells us that there is 1. When we have more than 1, that's when we write a subscript. So we have more than 1 hydrogen. We put this little 2 behind it because sub means behind or below. Sub, so this 2 is below the hydrogen. Let's do another one. So we're going to be doing the same thing. So what I want to do first is I want to count the number of elements and atoms for this compound. So I'm going to write it down and let me switch screens. 2CH4 and the other compound is CaOH2. So this is what we're really going to practice a lot. All right, so I'm going to make a T chart and I'm going to have elements on one side and atoms on the other. Now in this compound, I have carbon and I have hydrogen. So I have 2 elements total. But I have this 2 right here, guys. This is called a coefficient. A coefficient goes in the front of your compound. It is a big number. And this coefficient applies to everything it's in front of. So this 2 means that there are 2 of this entire compound. Okay, so there's 2 of these CH4. And that would look like this. So we have C, and then I'm going to put 4 H's around it. That's 1 CH4. That's 2. So we have 1, 2 of those compounds. So I have 2 carbons. And then there's 4 hydrogens in 1 molecule, but there's 2 molecules. So if I look at my picture again, I shouldn't have erased it. If you draw the picture, it makes it really easy to count. So I have 1, 2 carbons, and I have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. 2, your coefficient, times your subscript. Okay? All right, so let me do the same, but for calcium. My total atoms here is 10. We have elements on one side, atoms on the other. Okay? I have calcium, oxygen, hydrogen. Okay? Ca, which is bonded with OH. That's how I'm going to draw this. But there's 2 of them. This subscript tells me I have 2 of these. So that's what this picture looks like. Okay? So Ca, I have 1. Oxygen, I have 1, 2. Hydrogen, I have 1, 2. Okay? So I have 3 total elements, 1, 2, 3. And then I have 1 plus 2 plus 2, 5 total atoms. Okay? So before we look back at the pictures, for this first molecule, I have 2 compounds of CH4. That means that there is a carbon bonded with 4 hydrogens, but I have 2 of them. And I know that's confusing, but we're going to practice. And I'll draw the picture one more time. 2 versions. So I have C bonded with 4 H's, but I have 2 of them. Okay? 2 CH4. 2 total elements, 10 total atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And then calcium, and this is called calcium oxide. I have calcium, oxygen, hydrogen. And if we draw that, I have 1 atom of calcium bonded with 2 OH. This 2 goes here. Okay, so that's what that picture looks like. Yes. All right, so now let's look at our pictures. I have 2 CH4. Which one of these pictures has 2 molecules, 2 of the same compound? So when we look here, this one is the exact same as this. I have 2 of this. This square represents carbon, and that carbon is bonded with 1, 2, 3, 4 hydrogens. And this one is exactly the same. So this picture represents our 2CH4. Okay? This one represents calcium oxide. The triangle represents calcium. The circles represent oxygen. And the rectangles represent hydrogen. And I have 1, 2, just like this subscript told me. Okay? All right, so let's do another example. So here we have H2SO3, Fe2O3. So this is 2 hydrogen, sulfur, and 3 oxygen. This one has 2 iron and 3 oxygen. So I'm going to go back and draw. Okay, I'll need to write them first. H2SO3 Fe2O3. Okay, so when we have our formula, this is a chemical formula, I'm going to draw these lines down to separate them so that I know where the subscript belongs, because the subscript tells me how many atoms I have. Subscript equal to the number of atoms. Okay, so elements in this compound, I have H, I'm counting my capital letters, S, O. Hydrogen, sulfur, oxygen. Now, my H, this subscript, is right behind my H. This subscript tells me that I have two atoms of hydrogen. This S has no subscript, so that means there is one atom of it. When there is no subscript, it means that there is one, okay? There's one. And then oxygen has 3 atoms. So I have 3 total elements, and I have 3 plus 1 plus 2, 6 total atoms, okay? And that picture is harder to draw. For this one, I have, my elements are iron, which is Fe, and oxygen. Okay, and this subscript right here, that's right after the chemical symbol, tells me that I have 2 atoms of iron. And this subscript tells me that I have 3 atoms of oxygen. The way I like to differentiate between elements and atoms is elements are like your ingredients, and atoms are how much of that ingredient you need. So for this compound, the ingredients are iron and oxygen, but I need 2 irons and 3 oxygens to make that compound, okay? So we have 2 total elements and we have 5 total atoms. So let's go back to our picture. This one is going to be easiest to answer by counting the total number of atoms. So remember, this compound had 6 total atoms, and this compound had 5 total atoms. So if we go to this first picture and we count the shapes, we have 1, 2, 3, 4, 5, 6. And this model has 1, 2, 3, 4, 5. So this compound had 5 total atoms, and this compound had 6 total atoms. Okay? So I think the H2, we're going to check our work, H2. So H can be represented by these rectangles because there's 2 of them. S can be represented by this sulfur. S is sulfur, and it can be represented by this larger rectangle because there's only 1. And then I have 3 circles, and I have 3 oxygens. For this one, I have 2 iron. Whatever this shape is called, there's 2 of them. And then I have 3 of these rectangles to represent my O3. Okay? So I'm going to pause, and then let's answer some questions. Okay, so the question was, is it always easiest to just count the shapes? If you correctly calculate the number of elements and atoms like I did with my T-chart, then yes. So for this example, I found that there were 6 total atoms. And for this compound, I found that there were 5 total atoms. So when we look at our picture, just by counting the number of pieces or the number of ingredients, I was able to figure out which is which. There are 6 shapes here, and there are 6 total atoms in this compound. There are 5 shapes here, and there are 5 total atoms in this compound. For this one, there are 10 total atoms in this compound, and there are 10 shapes here. For this one, there are 5 total atoms, and you can see there are 5 different shapes, or five shapes total. Okay?